in this video we're going to talk about angles. And an angle is made with two rays, or when two lines cross, you form angles. And where those two rays meet, or those two lines cross, is called a vertex. So you can see a couple of examples here of conditions where we create angles. On the left, you'll see that we have two rays, and a ray has an endpoint, and then it's just a line that continues on in one direction. And these two rays meet at the vertex, and they form this angle. And on the right, we have two lines that extend infinitely in both directions that cross at the vertex, and we actually form four angles when two lines cross. There are four types of angles, and we have an acute angle, which is an angle that is less than 90 degrees. We have an obtuse angle, which is any angle that is greater than 90 degrees. We have right angles, which are angles that are exactly 90 degrees. And we have straight angles, and that's an angle that is exactly 180 degrees. And it's called a straight angle because it basically looks like a straight line. Naming angles. There are actually several different ways you can name an angle, and we've talked about this a little bit. One of the ways that you can name an angle is by using 3 points that are on the angle, 1 point on each ray and the vertex. So the example that I have here, we can name this angle as angle, using the angle symbol, angle A, B, C, or we could also name it angle C, B, A, and in both of those cases, the vertex is in the middle. B always has to be the middle letter, or the vertex always has to be the middle letter if you're using 3 points on the line. So that's one way we can name an angle. Another way we can name an angle is to name it by just its vertex. And the vertex of this angle is angle B, or the vertex is B, so we can call it angle B. Or if it has a number inside the angle, we can name it just by its number. We could also call this angle 1. So you can see that there are 4 different ways to name this angle: angle ABC, angle CBA, angle B, or just angle 1. So let's take a look at some angles here, and we're going to name it 4 different ways, and then we're going to classify it as acute, obtuse, right, or straight. So first, let's name this angle 4 different ways, and one of the ways we can do it is using the 3 points on the angle. So we could call this angle ABC, or we could call it angle CBA. We can name it just by its vertex, angle B, or we can name it by its number, angle 2. And what type of angle is this? Well, this angle is less than 90 degrees, so this is an acute angle. Next, we have this angle that is formed by these two rays, and we can name it by 3 points on the angle, angle RST, or angle TSR. And notice again that S is the middle letter because it's the vertex. The vertex must be the middle letter. We could not call this angle STR or SRT. S has to be the middle letter. Or we can name it just by its vertex, and the vertex is S, so we could call it angle S. Or we could name it by the number, angle 3. And this angle is greater than 90 degrees, so we would say that this is an obtuse angle. And then lastly, we have this angle here, and again we can name it using 3 letters, L, M, N, so angle L, M, N, or angle N, M, L. We can name it just by its vertex, angle M, or we can name it by the number inside the angle. This is angle 4. And you'll notice there's a little square or a little box inside this angle. That tells me that that's 90 degrees. So that is a right angle. Now let's talk about some types of angle relationships. So pairs of angles can have special relationships with one another, and one type of angle relationship is called vertical angles. And vertical angles are opposite angles that are formed when two lines cross. So you'll see in the picture I've got two lines that cross, and there's actually four angles that are formed. Angles 1, 2, 3, and 4. And you'll notice that the opposite angles, or angles that are opposite sides of the vertex from each other, are the same angle. So vertical angles will always be equal to each other, or congruent. So congruent in geometry means equal to or having the same measure. So angle 1 and angle 3 are vertical angles, and they are also the same measurement, or congruent. So the way we show that is using this notation right here. We say angle 1 is congruent or equal to angle 3. And that funny little equal sign with a squiggly over it is the symbol for congruent. Also, we have another pair of congruent angles, or angles that are the same, and that's angle 2 and angle 4. Angle 2 and angle 4 are vertical angles. That means they're across the vertex from each other, and they are also congruent. So vertical angles will always be equal to each other, and vertical angles are on opposite sides of the vertex when two lines cross. So let's take a look at an example here, and we know two of the angles, but we're missing the other two. So without measuring them, we can actually tell how big these angles are. So what are the measures of these missing angles? Well, I know that that top angle is 55 degrees, and that angle 1 is vertical to it, or across the vertex from it. So I know that it's equal to 55 degrees. So angle 1 is 55 degrees. I also know that angle 2 is vertical to this other blue angle, which is 125 degrees. So I know that they are equal. So angle 2 is equal to 125 degrees. So I can use angle relationships to figure out missing angles, to know how big an angle is just by knowing its relationship to other angles. Now let's take a look at this situation. We're going to have to use a little bit of algebra that we learned last chapter. So again, I have vertical angles here, so I know there are some equal angles. So let's take a look at x. We want to know what the value of x is. Well, I know that this angle, which is 2x, 2 times x, is equal to the angle that it's vertical to. So I know that 2 times x is equal to 42. And that's a simple equation we can solve. If we divide both sides by 2, x has to be 21 to make those angles equal. And then what about the value of y? Well, this angle, y plus 10 degrees, is vertical to 138 degrees. So I know that they're the same measure, or they're equal. So I just write that down. Y plus 10 equals 138. And again, a one-step equation that I can solve. Y equals 128. So y has to equal 128 because those two green angles are congruent. And to make it congruent, y has to be 128. And that's vertical angles. Another type of angle relationship is called adjacent angles. And adjacent angles are angles that share a vertex and a side. It has to be both. It cannot be one or the other. It has to be both. So looking at this example on the left, angle 1 and angle 2 are adjacent. And what makes them adjacent? They're like neighbors that share a fence. They have this side in between them that they both have in common. So angle 1 is created with this line and this line. And angle 2 is created with this line and the same line that angle 1 was using. So they share a side, and they also share a vertex. They have the same vertex and they share a side. So they're neighboring angles. So adjacent angles are neighboring angles. They share a side and a vertex. So let's look at a couple of examples of angles that are not adjacent. Angle 3 and angle 4 are not adjacent. They do share a vertex, but angle 3 is formed with these two lines, and angle 4 is formed with these two lines, so they do not share a side. They share a vertex, but no side is shared. So angle 3 and angle 4 are not adjacent. Likewise, angle 5 and angle 6 are not adjacent. Here, angle 5 is formed with these two lines, and angle 6 is formed with these two lines. You'll notice that they do share a side. They have this middle side in common, but they do not share a vertex. They have a different vertex. Each angle has a different vertex, so they are not adjacent. So let's take a look at this diagram. There are actually 6 angles formed in this diagram, and we want to name a pair of adjacent angles in this diagram. Can you find any? There are plenty here. So let's list out as many as we can. So I'm looking for angles that share a side and a vertex. Well, all of these angles share the same vertex. They all cross here. So now we're looking for angles that share a side as well. So I see that angle 1 shares a side with angle 2. So angle 1 and angle 2 would be adjacent. Angle 1 also shares a side with angle 6. So I could say that angle 1 and angle 6 are adjacent. Angle 2 shares a side with angle 3. So I could say angle 2 and angle 3 are adjacent. Angle 3 also shares a side with angle 4. So angle 3 and angle 4 are adjacent. They share a side. And angle 4 also shares a side with angle 5. So angle 4 and angle 5 are adjacent. And I think lastly, angle 5 shares a side with angle 6 as well. So angle 5 and, angle 6 are adjacent as well. So lots of pairs of adjacent angles. So the take-home message here is adjacent angles are neighbors. They share a side and a vertex. So here I have another diagram similar to the last one. I've got 6 different angles here, and we're going to look at angle relationships and identify them as either vertical, adjacent, or neither. So if you'd like to pause the video now and see if you can tell whether these angle pairs are vertical, adjacent, or neither, you can go ahead and do that, but I'm going to tell you what they are right now. So angle 1 and angle 2, here's angle 1, and here's angle 2. They share a vertex, and they share a side. So does that mean they're vertical, adjacent, or neither? That means they are adjacent. They share a vertex and a side. Angle 3 and angle 6, here's angle 3, and here's angle 6. They are across the vertex from each other. These two red lines cross, so they are vertical angles. Angle 4 and angle 5, here's angle 4, and here's angle 5. Here they share a vertex, and they share a side, so they are adjacent. Angle 6 and angle 1, again, here's angle 6, and here's angle 1. They share a vertex and a side. These are neighbors, so they are adjacent. Angle 2 and angle 4, this is getting kind of messy here. Let me try to erase some of this. There we go, that's better. Angle 2 and angle 4, here's angle 2, and here's angle 4. They're not adjacent. Are they vertical? They're actually not vertical because this is a straight line here, but this line right here is not a straight line. So these two angles are not formed by two crossing lines. So this is not vertical. These are actually neither. There is no relationship here between angle 2 and angle 4. But if you look at angle 2 and angle 5, you can see I can form those two angles with two lines that cross. They are across the vertex from one another. So angle 2 and angle 5 are vertical. So types of angles, we have acute angles, we have obtuse angles, we have right angles, and we have straight angles. And then we have angle relationships, which are vertical angles, angles that share a vertex, and they are across each other, across the vertex from one another when two lines cross. And we have adjacent angles, angles that share a vertex and a side.